Hello, everybody. I welcome you to my channel. Today is a day 2 of our Docker networking. On the day 1, we discussed about networking concepts and finally we discussed Docker and its CNN model. So I request you to see the first part and get some understanding on what we are doing. Today we'll get one more step ahead and we'll see how to create a custom network interface with interface type like veth. Once we do that, then we'll move on to simulate the container isolated network stack using Linux own network namespace, which would be very close to what Docker does with its container to enable network communication. Before we proceed further, let's have a VM or a server where you can demonstrate how to create the interface, how to create the namespaces, and finally we'll install Docker into that host. Okay. Now, being in DevOps, it's always recommended to use some of the ISE tools like Terraform to build the infrastructure. And this is my Terraform script. Basically, it creates a VM into the GCP, and it is pretty simple. It is pretty straightforward. Okay, script. Okay, so to start that, okay, I'll be using Terraform apply, but I have created an LIS, so it automatically does part. This is our VM, okay, and which actually we have got from the GCP, and this is where we'll be doing the drawing. Now, if you see its existing interfaces, we can use a command like IP link, and we can see that it gets two interfaces. One is the L0 and one is the ENS4. Now, if you remember that we have discussed in the previous video how we actually read these interfaces. It is saying that it is EN, which is interface, and it is the first ECI device, and it is uh, attached to the slot 4. So that's how we read it. Okay, this is just a side note. Okay, now what we have done is, so if we just put that in the drawing for basic understanding, so we have here Ubuntu operating system we have, and as you see, it gets two interfaces. Let's make it a little faster. It gets two interfaces. One is L0. Now, if you see its IP address, it is ENS4. If you see its IP address, IPAS, this is the command we can use to see the IP. And as you know, this is basically the loopback address, which is 127.0.0.1 and /8. It is on the first class A network, right? And from ENS4, which it says that it is actually on the 32. That means it got its own network. Okay, so let's just copy that for basic understanding and we'll put it here. So it gets IP address, and this interface basically gets the loopback IP address. So we really do not need to worry about that. Now, what are the things that we are going to achieve today? We are going to create a network interface today. Okay, and then we see how we can make a communication between the two interfaces. Okay, for that we have to create an interface, and to create an interface on the same machine. So what we are doing now, we are inside this Ubuntu now. We are going to create two interfaces. So let's make it ready first here. So I'll create two interfaces like that, and this will be attached to the host itself. Okay, and I'll give it some name, and this interface I'll give it a name like as isolated net, ISO net. Basically, it's like, host interface, host isolated interface, and this is the isolated network interface. So now if I take my IP link, add, and I have to give it as a name, it is hostnet, and we'll give it as a type as veth. Now, what happens to the veth, as you told, like it has one because an Ethernet always has two interfaces. So it has one interface as hostnet. So another interface also should have. So we'll keep that as a name is like peer name, and there should be a space. Peer name should be another interface that will keep that as we'll make that as both as a peer. Okay. So because we don't have sudo, so what we'll do is we'll be using the sudo and execute the ps command, and it should have been created. So if you see that it has executed this command. Now if you do something called as IP link show, we can see that it has two interfaces created. One is the hostnet, and one is isolated network. So one is a host network interface, one is isolated network interface. But you can see both of them are down. So what happens when you create an interface to an existing host, by default, its interface will be always down. Okay, so that's why what I made is I made it. Now we have to bring them up. So what we have done basically here is we have created two interfaces and we have connected using the veth type. So that means there is a virtual Ethernet connected between these two interfaces. Okay, and we have to bring it up also. So to bring that network up, we have to use, again, let's use sudo this time, sudo ip link, and we have to say what we are going to do. So we are going to setting this interface into up. So because it is down, so you have to make it up. So you do set, and then you have to use this. So you have to, since it is device, so you have to use device and this, and then what you are going to do with this, we are going to make it up. Okay, so that brought one of the interfaces as up, but we have to make this interface also up. So let's make this also up. Okay, now if we see the ip link show, you can see that isolated network is also up. At the same time, the host network is also up. But do they have any IP address attached to that? Answer is no. Let's see IPAS. If you type, you can find that isolated network is up, but there is no IP address assigned to it. So we have to assign some static IP address into that. Okay, so let's do sudo add. So what you're doing now is we're just assigning some IP address to this interface, and we can see if we can communicate using them. Okay, so I'll put an IP address here as in the network of 10.10.1.10, and I'll keep that as a class B, which is in the /24. Sorry, which is actually a class C, which is in the /24. And then make one more, which will be 1.15. Okay, so we are making these two interfaces. One is 1 with 10 and one is 1 with 15. So to get add an IP address, what you do is sudo. Let's first see the IP link show. The interface names are pretty important. We'll be using sudo. We'll be using something called as IP link address. No, we'll never use the IP link address to add the IP address. We'll be using something called as IP address. So ensure IP address ADDR. So we'll be using ADDR for that, and you're going to add an IP address. So we have to use the add into that, and what IP address we are going to assign. So as we discussed, we'll be assigning 10.10.1.10/24, and you're going to assign that to the device host net, right? So we're checking for this host net, and you're assigning this to host net, and this is assigned. Now if you do the IPAS, you can see that the host network got an IP address is 1.10/24, but the isolated network has not got any IP address. So we have to assign the IP address to the isolated network as well. So if we just do the up arrow, we need to change it to isolated network. The device we have to change isolated network, and here we're just changing it from 10 to 15. Okay, and it is pretty simple. Okay, IPAS, if we do, now we can see that both the interfaces have got the IP addresses. One got 1.10, another got 1.15. So this is what we have achieved now. Now let's see if we can see whether we can communicate with these interfaces or with these interfaces. So let's ping these interfaces and see if they're actually reachable or not. So now we are going again inside the Ubuntu, and from there we're just trying to ping these interfaces individually and see if they're working. So for that, what we'll do is we'll be using the ping command, and as you know that we are going to ping a specific interface, so we have to use the interface flag, and we'll be using, say for an example, we want to ping the interface as isolated network interface, and isolated network interface has an IP address of 1.15. I want to key, and I want to keep that as a count as 2, so that I don't want to have more and more responses. Let's see if that works. Yes, so we are able to, what we are doing now is just trying to ping this interface and it is working fine. We are not pinging it from the outside of the host, but we are actually sitting inside the host. From there, we are able to connect to this interface. And the similar way, if you want to do the testing, we can do and check the other interface as well. But this is host network. And this is also able to ping. All right, so this is just the first part we have created. We just created an IP interfaces inside the host and we are able to communicate. Now, this is just the first step. Now, what we are going to do is the second part of our video, which is the network namespace. Now, okay, we are going to see how we can make a network namespace. That means what we are going to do is we are going to create an isolated network stack. Now, this is one of the stack that we already have. Okay. But what you're going to create, we are going to create an isolated network interface. I mean, isolated network stack here using something called as Linux own network namespace. Now, this namespace, as I told earlier, this is not the same namespace that we use in the Kubernetes. This is the Linux own feature, which is used to isolate the network. Okay. And this is one of the things that Docker also uses to isolate its container network. Okay, so we are not isolating the container here. We are not isolating the container, but we are isolating the network stack. Okay, so don't think that this is a container, but it is just a network stack. Now we have to give some name to that, as the name suggests. Okay, we are going to create an isolated network. But the question is how we are going to create an isolated network. We know how to create an interface inside the host, but just typing IP link add command. But how we are going to create an isolated network? Now for that, my dear friend, there is some command. Okay, and that command is called as network namespace. In short, we call it netns. So if you want to see in our existing host, is there already some kind of network namespace there or not? Okay, for that you can use lsns command. LSNS means LS for the list, NS for the namespace. Okay, and we want to see the type as net because we want to see the network namespace. And we can see that it has some namespace already, but this namespace are the global namespace that the Linux host already uses. But what we are going to achieve now is we need to have a separate namespace. To create a separate namespace on the Linux, we'll be using command called as ipnetns. And if we push show, we'll see that there is no network namespace available. So we have to create a network namespace now. So for that, as things that we have. Okay, now if we see the show, we have created an isolated network. But the question is, if I do now IP link show, for an example, can I see what are the interfaces are inside this isolated network? Because basically, if I do now the IP link show, I'm able to just see these four things. But how am I able to see the interfaces inside this isolated network that I have just created? Let's see. If I create IP link show, what are the things we are seeing? We are seeing the L0, ENS core, isolated network, and host network. These are these four interfaces we are seeing. To go inside any isolated network, okay, we use exec, exec, and this is the same exec command that we use for the Docker as well as for the Kubernetes pod, right? So we'll be using the same thing. So now from the host, we want to go inside the isolated network and we want to see its IP network stack basically. Okay. So for that, what you have to do is, we have to use the same thing, sudo ipnetns and I'm going to start netns, and you have to use the exec command to go inside this isolated network. There's only one interface and that too it is down. So what we have seen now, let's draw it so that we can simulate it. So we see once you go inside that, we find there is an L0, but we want to have another interface into that so that from inside this isolated network, we can communicate inside the host to the another network namespace or to the internet. .co.in. Okay, so I want to reach from here to any of these hosts or any of the interfaces inside that, as well as I want to go to the out. For that, we need to have a real interface inside that. So what we'll do, we'll be taking one of those interfaces. Say, for example, I'm taking isolated network interface from here because the host doesn't need it anymore, right? So we'll be taking this interface. Okay, and now what happens, the moment we take the IP to take the interface out of the host and put it to the another network namespace, it loses its IP address. So there is no IP address now and there is no connection now, right? So now we have an isolated network. So, and we have to add an IP address. So first of all, we have to attach this isolated network into the isolated network interface into our isolated network. So this is what we are going to achieve now. So we have to use, so we don't need to use netns. If we use, now it got connected. Now if we go and see inside that, but for that we need to go and see, for that we need to go sudo IP netns exec, and to go inside that we need to know the netns name, which is like isolated IP link now. Now we can see that it has an isolated net attached, but it is down. So the next logical thing that we have to do is we have to bring it up. Let's see it has an IP address, IPS show. It doesn't have any IP address. So two things we have to do. First, we have to bring this interface up. So now it is down and we have to attach an IP address. So I'll be attaching the same old IP address to that. Okay. And both will be in the same network. Okay. So first of all, you have to bring it up, then you have to attach the IP address. So to bring it up, what you have to do is you have to do, and this dev is IP net, and you have to bring it up. Okay. Now if you go and see IP linked inside that, it will be showing as up, but there will not be any IP address. There is no IP address yet. So we have to again assign an IP address. So to assign an IP address, we have to use something called as we already want to assign this IP, let's copy that, paste it here. And where you want to assign, we want to assign this to this interface. Now let's see the IPAS inside that, and we see that it has an IP address. Okay. Now since they are both on the same network, so there should be some kind of communication. Now we want to see the communication between the host. So what I'll do again, I'll have to go inside that, and from there I want to do something called as ping, and I'll be putting this count as 2 so that I can get only 2 output. So let's see if we can communicate. And we are able to communicate. So that means the connectivity between this and this is already there. But can you communicate with this network? Let's see. And it says that network is unreachable. So what is the reason? Because it is in the 10 network and this is in the 192 network. So obviously there are two different network, and if the two different network wants to communicate, it can possible only through the router. So the next possible thing that we have to do is we have to see what kind of routing table are there inside this isolated network, right? See, what I'm trying to show here is this is the step-by-step way of doing the networking and its troubleshooting. What I'm teaching now is all about how we can think from the network point of view, and if the problem comes, how we can think. So based on this error, I can find that it is in a different network. So the next logical thing I'll think about is if there is any router, or if there is any router, then is the IP table set incorrectly. So what I'll do, I have to go inside this again to my isolated network host, and I'll be checking its. For that I have to use IP route. Where am I? I'm going actually inside the isolated network. Inside this, I'm now, and I'm trying to see the IP route of this. Okay, so here it says that it has only one route, and that is it goes only to its own network. That's all. It doesn't know anybody else. Now we have to assign, we have to create an route table inside this isolated network so that it can communicate to the other network as well. Now to create an isolated network, we have to use same thing, but IP route, you have to use something called add. Now, if I want to communicate with this network, I can just write this network here. Okay. And I can say like buyer, it has to, if you ask to go and hit this network, it has to go by its partner, which is the peer, which is this network. Sorry, this IP address. But it is really not good for me to just assign a single IP here. Instead of that, what I'm going to say here is, if it wants to go anywhere apart from this, because it knows how to go to its own network because it already has a route table. As you see here, it already has a route table. What I can make that, apart from this network, if it wants to go to any network, okay, it can go, but it has to go through this. So for that, rather writing a single IP here, what I can write here is I can write something called as 0.0.0.0. But instead of writing 0.0.0, I can write something called a default. That means any network. Any network, it can be an internet also, if the host allows. Okay. If I see its route table, I can see that one more route got added into that. Yep. So you can see that it is going to the default via this network. Okay. So now if we want to try to ping, now you can, if you can ping not this network, but this network, it will check its route table and it is finding that, okay, it can go to any interfaces through this, okay, via this, because this is only speared network, and through this it can communicate to the any network. Now let's see if it pings. Yep, it is able to ping. Now let's move little ahead now and see, can we go outside this host now? This is the most interesting part. So inside the host, everything is working. I can reach out to this. I can reach out to a different container or the different IP address. So this is just basically a simulation of connecting to the different network. But what if I want to go to the internet? How can I go? Is it going to work? Let's see that. So we'll be using ping-c, or let's do as 2 counts, and I'll put the yahoo.co.in here. Do you think it will work? Please write it on the comment. Now, the answer is it will not work. The reason is inside this isolated network, there is no DNS configured. Now, you can see that it is finding that it is name resolution failure. That means it is not able to resolve this name into an IP address. Okay, because we do not have DNS. So let's try to connect to its IP address. We can use something called as dig command for that. Sudo dig -t, type a record, and I want to put yahoo.co.in, and I would get short. I press enter, I get an IP address. So this is the IP address. Let's try to see if I can communicate. So what you're doing here, let's see again, from the isolated network, I'm not only trying to connect to this, but I want to trying to connect to, and it did not get. The reason is inside this host, everything is fine. Okay. But if it wants to go outside the host, it needs to have some kind of routing enabled or some kind of firewall rules enabled for that. Okay. And for that, we can use something called as IP tables. Let's see if there is any kind of existing IP table already available. So sudo IP tables -v-capital L, and you want to see the type as NAT. Okay, so we see that there is no IP tables at all. Okay, so we have to create the first IP tables. Why we want to create an IP table? Because we want the traffic from this isolated network to go to the internet via this interface, ENS4 interface. So through this interface, we want to connect to the internet. Let's see how we can achieve that. So we are going to create an IP table inside the host now. Okay, so what IP tables we are going to create is, we'll be just typing IP tables, and we are going to use so this is one of the notes that I have made. Okay, if you want this note, if you want this image, I can attach that into my LinkedIn profile, but for that I need to get at least 30 comments so that I know that whoever is seeing this, they are serious about that. I can definitely attach that to my LinkedIn, and you'll be getting to know. So here you can see that it has a different type of tables. Actually, there are 5 types of table, but I have mentioned the 3 because these are the main. Then there is something called change. This is basically the rules that we apply, and there is something called the actual rule, which is again having 2 types, matching components and the target components. So let's try to create an IP table. As is, we have seen that there is a type called net. So the reason is we want to change the IP address when the packet goes from one host to another host, or it goes into the internet. Okay, it has a lot of headers. One of the header is what is the target IP, what is the source IP. Routing already happened, and after the routing happened, when the traffic wants to go out, it has to attach something called post routing into that. So that should be writing post routing, which is like A, and we'll be using post, or UTING, post routing. And after that, we'll be using something called as source. Source means what is the source IP when after the routing happens in the header. What should be the source IP? Actually, the source IP is 1.15, but I want to say that when you go out, don't go as 1.15, but you go as my default network. So go it for, okay, and you use this output as the interface. So we're using -o, I'll be using ENS4, and after that, if you find if you do that, then jump into something called as Masquerade. Now if you assign this, now the traffic comes, it will see the IP table rules, and then it will forward that to any internet, because we already have made a route table here that it can go to the internet, because we have given the default, right? So it means it can go into, so that means route table is allowing it to go outside, but the IP table rules are not allowing. So if we can make the IP tables rule and enable that, okay, hope it works. So let's go and try to see this. So now you see there is no IP tables. Now if you can make an IP table, sudo the same IP tables, I'm just copying and pasting here, right? Sudo IP tables. Now if you see the existing IP tables, now you can see we already have an IP table in the post routing. In the post routing, we have an IP route. Now let's see if we can reach out to the internet. We'll go to the, again, look, we are going inside this, and now we're just trying to see if we have the communication to the outside. So the first, the traffic will come here, then it will go here, and from there it will try to go outside. Now let's see if it goes outside or not. Okay, we have to go inside the isolated network namespace. Then from there, we're just trying to ping the A record of the Yahoo. And if we see, no, it is still not. The kernel doesn't want that traffic to go out, or the traffic as a forward to go out. And to see that, we have something called as kernel tunables. And to see all the kernel tunables, we'll be using a command, a tool called sysctl. And you want to see all. And what I want to see is why it is not forwarding it, right? So I'll be using grep I, and I'll be using something called as forward as a keyword to see if we can filter something. Okay, so this is something that I'm talking about. So it has this, see, it is going to the net, and from there it is looking for IPv4 and is trying to forward, and it is by default it is disabled. If you want to enable that, again we can use the same sudo, we can use something called sysctl, and we want to write it, right? So that we want to write, and instead of 0, we'll just make it 1. Now it has made this as a 1. Now let's see ping. Let's see if the ping happens to the internet. And as you can see that we are able to establish the communication from the isolated network through this ENS4. It is going inside to the internet. Okay. Now, do you think this is the same thing Docker does? And answer is quite similar. Okay, but it is using the host network. But if you want to see what Docker does, Docker has different types of driver. One is the host driver. One is something called as bridge driver, Magdalene. Now, the second use case that we want to see here is we are not going to use the host network. Instead, we are going to use something called as bridge network. Okay, but before the bridge network I want to show there is any bridge available or not. Sudo su-brctl show, and I want to install this utility so that I can show you what is the difference between writing end and the semicolon. Please write it in the comment. It is very important concept to understand. Okay, let's see what we are trying to achieve now. So till then, what we have done is we are using the host network. Now we want to create a bridge network. Okay, we are not going to use so this network, and this network we have created by typing veth, right? So we have used something called veth, and we have seen there is one more type of network there, and that network name is bridge network type, right? So we'll be using the bridge now. Okay, so what we are trying to achieve now is I'll create another switch kind of thing here. Okay, it is a switch, and I'll give it a name. Let's change the color. I'll give it a name as BR0 or BR01 as bridge, and we don't need this host network anymore. Okay, but This is an interface. So what we are going to do is we are going to put this interface here. Now, since it is a bridge, so obviously some interface should be connected to its port, right? So say for an example, this is my host network. This interface name is host network. And now this is connected directly to this interface. And the bridge will be having this network. So what is the network that we're going to assign to the bridge is 10.10.1.0/24. This is the bridge networks. This is the bridge network. And this interface doesn't have any IP address now, because obviously when you attach something to a switch, only one interface is attached to the device, another interface attached to the bridge, to the switch. So it should not have any IP address. We really don't need that. So if we can make this configured, so again we have to create another IP table. So maybe we can use the existing IP tables to show. Okay. So now we are going to create a bridge network. We're not going to create any host network now. So let's see how we can create the bridge network. Okay. So my brctl is installed on my host, and let me go into my user. Now if I show is there any bridge network existing on the system or not, further we'll be using the command called sudo brctl and using the show, and you can see that there is no bridge network into the system. So what we're now going to do is we are going to create a bridge network. We're already creating a bridge network with the name of BR0. So let's create that first. IP link, and we have to use something called add, because we're adding this BR0, and we are using the type as bridge. BRIDJ bridge. Now if we see brctl show, you can see the BR0 is created, but there is no interface attached to that. Okay. We have just shown the image that we are attaching this host network. Now let's attach this host network interface into the bridge network. So to attach interface into the bridge network, we have to do call same thing like the sudo IP link, and you have to use something called a set, and we'll be using the master, and the bridge network name is bridge0. Okay. Now if you see the brctl show command, we can see that interface is already there. Host we are seeing now IP link show, and you can see that BR0 is actually the down mode. So we have to bring it up. So to bring that up, what you can do is we can do the same thing, sudo. Now we might be very experienced now, sudo IP link, and then you have to set, and you have to give the name BR0, and you have to make it up. Now you can see that it is up, but sorry, it is up. But is there any IP assigned to this BR0? Let's see IPAS. BR0 doesn't have any IP. Sudo IP at TTR head, and here is sending 10.10.1.1, which is actually the default gateway. Here is sending the default gateway into the switch, and it is using as DRS BR0. Now if we see the IPAS, we can see the bridge got an IP address. So what things we have done now so far is we have created a bridge network, which is BR0, assigned an IP address, basically the gateway of the network we have assigned to that, and we have brought it up. We have assigned a network interface also. Now we want to see whether still we are able to go to the internet or not, because we already have the route table and we already have enabled the IP forwarder as enabled, right? So which is made, we set the value as 1, which is enabled. Now let's see if we can still communicate. For that we need to go inside that, and for that we have to use sudo IP netns, and we have to use exec, and we have to give the name of the network namespace, which is isolated net, and let's try to ping count as 2. I forgot the Yahoo, so let's put some global network dot 8, and you can see that it is not able to communicate. The reason I'll tell you, if you go here and see IPAS, you can see that the host network also has an IP address, but we know that whenever any interface is connected to the switch, it should not have an IP address. So first of all, we have to remove the IP address from the host net. This is the step by step. This is how we can do the troubleshooting. So to remove the IP address from the netns, what you have to do is we have to use sudo IP So IP ADTR. We have used add before to add it. So we are going to use delete now. Delete delete what IP? We have to delete this IP /24 from device hostnet. Okay. Now if you see the IP AS, you can see the network of hostnet interface doesn't have any IP address. Now let's see if we can ping the internet or not. Now if you see here, now it is not able to ping. We have removed the IP address from the network. So we have removed the IP address from the host net, but still you are not able to connect to the internet. Now, one thing that we can do is we can go inside this network, isolated network, and we can see what is the route table assigned to that. So what you can do is you can go inside this and you can see its IP tables, so IP route. Okay, so here you can see that it can go to the internet, but it says that it has to go only through this IP. But there is no IP like this, because we have removed it. We have to assign that it can go to internet only via the bridge default gateway. So we have to change this from 1.10 to 1.1 because that's where it has to go through this network now, right? So how we can do that? So obviously again we have to go inside this IP route, and what we did, we have added add and IP route default via. So what we have done before, we have done add here, default via what we have done before we have used this IP address. Now you're going to change, and now before that you have to remove it first. So to remove that, and it should be delete. Now if you see and go and see the IP route, there is no route. Now we're going to create a new route, and we'll be using the add here. So what we are doing is we are assigning a new route table inside this, that it can go anywhere, but it has to use this IP now. So you're using 1.10. Now we have assigned the IP. Now let's see we see its IP route now. It says that it can go anywhere through this bridge network. Now if you want to see, now if we can see whether it can go to the internet. So traffic comes from here, hits here, okay, and from there it has to go to the internet. Let's see if we can see that. For that we have to again try to ping -c 2, and I'm putting a global network 8.8, and we can see that now you're able to go to the internet. So it simulates our second use case. The first one was using the host. Second one is using the bridge network, how we are going to communicate to the outside. We can use some other creative ideas to even map the port number as well using a different IP tables. We have got the idea. Now we can try it ourselves. So this is the basic idea. Okay. Now, if this all makes sense now, we can go into the Docker installation and we can see how the Docker network works. Okay. And it will be pretty easy for you to understand now. Now let's see what are the IP tables we have first of all before we move, right? So sudo IP tables hyphen v small v hyphen capital L hyphen n net. Yes. So it's type. So you can see that there is only one IP tables assigned. Now let's install the Docker in the same. But before that, I will show you what are the brcpl show. We have only one bridge network. Now the moment we install the Docker, obviously one more bridge network comes. That's why I'm just showing that existing bridge network is already big. Now let's install the Docker into that. And for that, I'll be using the default. Okay, so this is what it is saying that you have to use that. So what I'll do, I'll just copy that and I'll come to my host. Rather pasting everything one by one, what I generally do is I create a script kind of thing and give you the name is Docker shell. And here I paste everything so that everything happens at the same time. And I'll use this also. And to execute a shell script, we have to give it execute permission. So we chmod plus x to Docker show. Okay, now it got executed. It got execute permission. Now we can just execute that. To execute it, we need Docker sh. And now let the Docker runs it installation. And I'm just pausing the video, and once it is installed, we'll start from there. Now, since the Docker is installed, let's see the interfaces of our host now. So we have installed the Docker in this. Now we want to see the interface. Okay, so this is the host. This is our Ubuntu, and in that we have installed something called as Docker runtime. It's not called Docker runtime. Docker is just a tool, management tool, and it uses runc as the runtime. I'll show you that. So we have installed the Docker. Now, once we install the Docker, it automatically creates an interface. It automatically creates a bridge network called as Docker0. So if you see now called as IP link showing, we can see that it has got a Docker0 network and it is in down mode now. Okay, so what happens is it created a network, but it is down. We are not doing anything here. So Docker will be doing everything. So let's see brctl show. You can see that this is our own network that you have created, and Docker0 also has, and it has no interface attached to it. Okay. Now what you are going to do is, now let's see what are the Docker. Once the Docker installs, so we have to see the Docker network automatically comes with its own network. Now Docker network ls. Now we'll see some error. It says that permission denied while trying to connect to the Docker. The reason is we are not using sudo, and we really don't need to use a sudo, which is not good practice for the Docker. Now, why we need to, why you should not use a sudo and why we have to directly communicate, I'll show you something. So if you go to Docker sudo find name, and there is something called Docker sock file. Sock is actually one of those files which any services uses to communicate with another service. So we have to go and find the Docker sock file. If you see, the Docker sock file is actually inside the run. So if you go and just type ls-l on this sock file, you'll get the answer. Okay, here you see, it is actually srw means it's a sock file, the socket file, and who is the owner of that? The user, the who owns is the root, and what is the group which is owning this? The group is the Docker. That means if I can add myself, who am I? If I add myself into this Docker group, that means I can do anything as what the root user can do. Now see who all are added to this Docker group. So for that, you have to use something called as sudo get entry, and we want to know the group Docker. If you see that Docker has nobody except himself. So if you want to add myself into this Docker group, what you can do, using the basic user management tool called sudo user add or user mod. You're modifying, so you'll be using user mod, and in appending to his existing thing onto the group. Which group you are going to use? You are going to use the Docker group, and who you are going to assign this to? You are going to assign anybody who is having the current user. Okay, that's all. It's simple. Now, if you go and see the get entry command, you can see the path is added to that. But to make it an effect, okay, we have to use something called, we have to refresh that. So there are two ways you can refresh. Either you can sign out, log out and log in, or there is a way that you can do something called new grp or new group, and you have to give the name and who is doing it. The same user is actually using this. Now, who is the user? Arthur is the user, so he is putting on his terminal as new grp and using the group name Docker. Okay, that adds himself to the group, and he can now perform any command on the Docker without even typing the sudo. That is one of the reasons why we always add ourselves into the Docker group. Okay, this is the basic reason. Okay, and I have seen in many videos, nobody actually explains that, but this is the reason, because it's a sock file, and sock file is the one which is actually being owned by the root, and the group is the Docker. That's why we're adding ourselves to the Docker group. Now, if we try to see Docker network, Docker network ls, we can see that we don't have get the permission error issue, but we are getting that it got 3 networks already installed using the bridge driver, host driver, or null driver. So there is nothing, right? So now what is this bridge driver? So this is the same driver that you will see if you type brctl show. This is the Docker0 network, which is the default network. Okay. Now let's create a container into that, and then we'll see. So for that, Docker network ls, we have seen that is good. Now I'll show you that when you create a container, okay, IP link show, and it is Docker0, it is down. Now if I'm creating, the moment I create a container, it will automatically become up, and it will give the IP to that container in the range of its 170 to 17 dot some IP address it will get, that we are going to see now. So to create a container, we'll be using Docker run. We can give some name, hyphen name. Let's give this the first container pass. Is the first container, and we'll be using the image as 1, 2. Now the problem is, if I run just like that, what will happen? The container will start and it will automatically stop because it doesn't have any entry point. Now when you write something in the Docker file, there is some instruction you write, right, as an entry point or CMD. So those instructions along with this argument, whatever things that you pass on them, that is the first process that runs inside the container. Now we are not using any Docker file here, so we're just using the Docker run command. So we need to put that entry point command also here, so that some kind of process it should run. And the argument that we can use here is, we can use sleep 3600. That means almost 1 hour it will run, and it doesn't find the Docker, it doesn't find the Ubuntu on the local, so it is actually going and downloading from the Docker hub. Okay, and it is done. The thing is, we have not put that on the background, so it is actually sitting on the same. So if I put Control C, will come out, and if you see something called Docker PS, you can see that one container is already running, which is started before 44 seconds. Okay, now if I see something called as IP link show on Docker0, I can see that the state is up. And if we go and see the Docker PS, it got a container ID. So let's try to go inside the container ID, and then we'll see what are the things that we can see. Let's do some inspection on that. So what we'll do is, we'll be using Docker. Again, you'll be using the exec command to go inside, and we need to give it some kind of, because since the process is running, we need to give some kind of interface and a terminal, else we will not be able to do that. So after that, you have to put the container ID, or you can put the container name, and then what are the things on which shell you want to go. Either you can go at being as shell sh, or you can go with the bash sh, bash shell. Bash is always good because it is useful because you can do some kind of auto completion of IP commands and all those things. So I'm doing it bin dash. Now see, where am I? I'm inside the container now. Now if you see something called as IP link show, okay, now there is no, we have to install that, and to install that, let's install that. We'll be using apt update -y, and once update is done, then you install I think it's called IP out2, and we'll be putting it y. So now what you're doing is, we're installing these packages inside the container so that we can see its IP configurations and the other things. I don't think so it will take much time, so it will be finishing, and we can go from there. Okay, so now the things are come in. So now the packages are installed inside the container. Now if we go and see the IP link, we can see that inside the container has got something called eth0, and it is actually automatically been up, and it should be getting an IP address also. We see IPAS. You can see that it got an IP address in the range of 172.17. That is the same IP of the Docker0 network, which is 17.0.2. It got the IP address. Okay, now if we see if we can go out to the internet or not, obviously I can see and we'll give 2 as a count and we'll paste the IP address of 1.8.8. Right? Okay, it doesn't find the ping command, so again I have to install the ping. But basically, we can definitely go on outside thing. So let's exit out of it, and I'll show you something. So now we are again on the host. So inside the host, now if you see IP link show on Docker0, will you see that it automatically went up, but we have not done anything. In our previous, like in manually, when you created that, we had to use IP link set and we have to bring that up and we have to use the IP address and all those things. But you can see everything is done very carefully by the Docker itself. Okay, so everything is up. Now, if you see the IP Docker network elements, it created. Now can we create one more network now? Let's see how we can create another bridge network, and then we'll see what are the differences between this, and that's how we'll just end the video here today. Okay, so we'll create Docker network create, Docker network create, and you have to give the driver as which, and we'll give this some name like my bitch. Okay, spelling mistake. So it should be Docker network. Okay, so it created a Docker network. Now if we do something called Docker network ls, you can see that we have my bridge network as well. Now if you want to inspect this, so how you can inspect Docker network inspect, and I'm going to put this, and I want to put that as a grep. I want to see its gateway. Grep gateway as it is giving us 18.1, and the default network, which is a bridge network, which is the bridge name. What is the gateway of that? You see, you can see that the default gets 172.17, and the second one that we have created manually got 18 network. Now, if you want to create any container in this network, that means this is isolated from this network. This cannot even communicate. So that's how two networks can be created inside the host. So basically what we are doing here is, so first it has a Docker0 network. And now what we have created is, we have created one more network called MyBridge. So it is like two different networks. And this got 172.17.0.0, it got 172.18.0. So obviously this will have its own containers which can communicate, which can go out and all those things. And this will have its own container which can go out to the network, but they cannot communicate. If you want to establish communication between these two, okay, either you can put some routing table configuration, all the stuff. Else you can, if you want, like all the containers should communicate. So it's best practice to put them inside the same network. Okay, so now I hope it makes sense now. So if you can now, if you want to practice along, you can create a container on this network. You can create a container on this network, and then you just try to ping each other and see that will never be able to communicate. If you want to be more and more creative, just try to create a route table and see how they can communicate, or else put everything under the same network. Now, before I go, I want to show you something called as, now what is the status of the IP tables. I'll show you how the Docker automatically creates the IP tables. It doesn't need our help. So if you keep IP tables -small v capital L, and I want the type is net, NNT. Sorry, and net. Okay. Now here you see Docker automatically creates network. And first case of the Docker0 network, and the second network is the BR0. So if you see BRCTL show, Okay, you can see that br0d, br0d, and br0. So this is something that we have created on our previous one, and Docker0 is something that Docker created, the default network. Okay, and this is something that Docker is using from anywhere to coming in, and this is something for the masquerade. Okay, so this is where, again, from inside host to outside world it creates. So this is something that we have created. These two are created by these two networks. Okay, so one is a Docker0 network and one is this now network. So similarly, other things are also there. Other IP tables are also, you can check like that. Okay, so using this, we can try and create multiple things. So I hope you have got some basic understanding how the Docker networking actually works. Okay, so there are a lot of in-depth things are also there, but this is just a starting point in how we can uh, you know, go reverse and see how the Docker network actually works. Now, if there is any issue comes in the Docker network related, you know exactly how to find it. So what I suggest is always try to create an drawing like this, which is basically an architecture diagram that will definitely help you that where you are going wrong. Okay, are you going wrong here? You are going wrong here. Are you going wrong here? Or on the IP tables. So it is always good to create some architecture diagram like this, and that will make your 70% of the troubleshooting very easy. Okay, you can save more than 70% of time just if you can put everything in the image, and things will be very easy. Okay. Okay, with this, I would like to end our session today, and I would encourage to practice them as they are very fundamental. And if you don't practice, I'm sure you'll definitely forget that. And what important is you need to remember the sequence, on what sequence we have done something, right? So I wish you all a very best, and we'll be seeing each other on a different amazing video. Please suggest what are the other videos that you want me to go in depth and show, so that I'd be happy to do that. With this, I would like to end the video. Thank you so much for being so patient. Thank you.